So, the modulus function.
Yes, chapter 2 from this book.
Oh yes. So Wayne, what's the modulus function?
Well, really...
Wayne, we forgot to do a clever intro.
Oh, I've got it.
Okay.
Yeah. Like, we could either be standing here, and we'll just swap over in like a little jump, and then swap backwards, and then jump in, and then just not refer to it whatsoever, as if we hadn't done it, and then just carry on.
Oh, I think I've missed it. You just keep going and just roll it. Ship sails.
Should we do that one next time?
Yeah. Okay. Alright. So, modulus function. New thingy.
Yes. It's referred to as the absolute value of x. So if it's mod x, it would be the absolute value of that. You could think of it as its distance on a number line from 0.
Yeah. So distances from a place are always positive. You can't be negatively far away.
So the mod of 3 is 3 because it's 3 units away from 0 on a number line.
But also, mod of minus 3 is 3 as well, because it's still 3 units away from the 0 number line.
And that's what the modulus is all about, but unfortunately, you don't just randomly plonk numbers in.
No, it does get a bit more complicated than that. That'd be nice in the exam.
Yeah, just, what is mod minus 4?
Oh, we got it! It's 4.
But
Nailed
no,
it.
you got to do graphs.
Lots and lots of graphs everywhere, and they're very bumpy.
They are very bumpy.
Mm.
Not good.
So it's just that.
Okay. So if we have, say, a nice simple one, y equals x plus 2.
That is quite a simple one. So if you draw an axis of this,
that would look something like
that's going through 2. Yeah.
But if we had mod of y, and y equals that still, the same thing,
then basically everything that's negative here will become positive.
so all of this just flips up.
It sort of reflects using the x-axis.
Like that, yeah.
Like that.
And that's what it does, and it does that with all of the graphs.
All of them, and some make strange shapes. This one wasn't that bumpy, but say a quadratic graph would, the modulus of 1 would sort of do that.
Yeah.
Because the negative bit would be flipped.
Where it would normally do, say, that.
Yeah, making a mouth.
And you know what does look funny is the sine graph, the mod of that.
Because it's just crazy hills forever and ever.
Just like that,
And
whereas that would normally, of course, do that, and then go up and do that.
It just keeps going.
And as I've mentioned it, I mentioned it because it does still come up. Like in core 2, you've got to know your radians, all that jazz with your cosines.
And then I'll start involving the stuff from the last thing about domains, ranges, and you have to know where these go through and sometimes when they intersect.
So chapter 1 neatly ties in with the modulus function.
And it's used throughout a lot of this course, actually.
It is actually, yes.
Building block.
Absolutely, much like in core 1, you do your straight lines and then that later intersects with circles and stuff.
Pretty much the same sort of jazz, but with the modulus.
And functions. So, let's have a little go at solving some of these sorts of things.
I think you should.
So, rub this off.
All gone.
All gone.
Magic.
We have something like this x plus 2, and we're told it equals 3.
Okay.
First thing you do, or first thing you should do, is draw this x plus 2, the y equals x plus 2, which we've just done. Let's say it's the mod of that. So we've actually just done this particular one. And it equals 3 in the y. So 3 is, if that's 2, it crosses at 2, 3 would be about here. And you'll notice there's 2 possible x's.
It gives a many to one function. So you have to find out both these.
Yes. So you have to find out what this x plus 2 equals. Now, because this part is being made positive, this part could have actually been a negative, but because it's mod, it was made positive.
So you sort of have to work it out twice.
Once with just the x plus 2 equals 3.
Yep, you need to work out what x is. X would be 1 in that case. And then you put a minus in front of it, as if it could be the other one.
Yes, because it's not, because it's mod, but it could have been. So
Could have been.
So as Triv said, that one actually equals, because you take the minus, go over the minus 2, it becomes 1. This one would be minus 5. And then you've got to look at your graph, which you should be pretty good at drawing by the time it comes to the exam.
Yep. And then you'll notice that this you just write as 1, and that would be -5.
Absolutely. I mean, that was a fairly simple one.
That was a fairly simple one, but it does get a bit more complicated, and they do intersecting stuff.
So I think we should get on to an intersecting example right now.
I think we should find one.
Let's go.
Okay. So now I've got some worked examples of some intersections.
Yes, we're going to go through the 3 major types. There's the modulus with a normal graph intersecting.
Yep. 2 modulus ones.
And then a modulus with a normal graph again, but as an inequality.
Yeah, a bit more complicated. So let's start.
Yes, so we're going to start off nice and simple. You've got a modulus graph and a normal graph, and they intersect. So I'll give you the example.
Alright. So
we have a y equals mod 2x minus 1, and then y equals x. And they intersect at 2 points.
okay, the first thing to do, I think, is draw them. I think it's always helpful.
It's always a very good plan, and you can visualise what you're actually doing. You can see where the intersections would be, and it just makes more sense in your own head.
So I'll draw y equals x first, because, you know.
And that's not had mod or anything to it, you just leave it as a straight line, and you should be familiar with all the standard y equals x is y equals x squareds graphs, and it looks like that.
Then y equals 2x minus 1.
So it's going to go through the x-axis at a half.
Yep, and through the y-axis at -1.
Yes.
Well,
And it's going to be a
was
little bit steeper up here than this one.
Because it's modulus, it won't go through at -1. It will reflect instead. And fly upwards. Like that.
So it would have gone down there, as Triv said.
But it doesn't, and now we can see it does, in fact, intersect at 2 points.
Here and about here.
So now for working out what the points are.
Yes. Now, as we have actually just done, you've got to treat this as both a positive and a negative. Like when we had the example equals 3, it could be plus or minus 3.
It's sort of like having 2 different graphs to play with.
Yes.
So first you do it as it is.
Yep, and that would be this side, the positive side.
Yep. So 2x minus 1 equals x, as they both equal y.
If you take the x over that side, that brings it down from 2x to x. If you take the 1 over that side, it becomes positive.
So x equals 1, and as y equals x, y equals 1.
And that
So
would
this
be
one.
quite clearly that point.
Yep. So that'd be 1. X, that's about right, because that's about half. And this would equal 1 as well.
And you can tell that because we did the positive mod and this is the positive arm.
Yeah.
You can also tell it from our graph as well, as Triv just said. So there's 2 ways of telling which of the 2 intersections it is.
Yep. And now we need to do the -1. So to make it minus, we put a minus in front of a bracket, imagine it's a bracket but a minus, and I give you minus 2x plus 1.
Minus 2x plus 1. And then that will equal x again.
Yeah.
You could take that over that side.
That's what I'd do. So you'd have 1 equals 3x, or 3x equals 1.
So then x would equal
A third.
a third, which again, you can tell from the graph is right.
That
Because
right?
less than a half, but more than 0. It's going to be about there.
And because, again, equal a third both sides. So that's that.
And that's that.
Pretty simple.
And that's a modulus equaling a normal graph. Now we've got mod and mod together.
Yeah.
Now that takes a bit more understanding if you want to save time, so that takes a bit more explaining. So if you want to rub it off, I'll quickly get the example.
Okay.
Now if you are working from the same AQA book as ours, which is this pink one here, it's on page 30, it's example 4.
Alright. So, what am I writing?
Mod 3x minus 5 equals mod x plus 1.
Alright. So again, I think we should draw it.
Definitely should.
Then we should do 2 different colours as well.
Okay. I've got red.
Got blue.
Okay, I'll do this one.
Okay. And I'll do x plus 1. So it would be there.
The x plus 1 is less steep lines than this one, because this is a gradient of 3, this is a gradient of 1, and that's, you've got to look at that sort of thing. And this is going to go through positive 5/3, and it's going to be rather steep, something like that.
Yeah. Now this is pretty helpful straight away, because now we know it only really intersects with our positive arm of this graph.
Yes, and that's important. When you look at these and you do the plus and the minus, you only have to do that if it's actually the plus and the minus. Now you know it's the plus and the minus because this is the plus of the normal line, and then the normal line would keep on going into the negative, so this reflected one is the negative arm, as you will.
Yeah, and that's how you'd tell. So that means we only have to do it twice. We could have done it 4 times. We'd have to do the positive, positive, minus, minus, positive, negative, and negative, positive.
But this time we don't have to, because we don't have to do negative of this one whatsoever.
No, because we know it doesn't intersect by looking at it. So we just do the right arm, so let's get rid of that.
Okay, so first we've got the positive with the positive.
Yep.
So that's
x plus 1 equals 3x minus 5.
just like that.
Just like that. So take away 1x and plus 5.
That gives you 2x when that's taken over, and then equals 6. So x equals 3. And that's going to be that one.
Yep.
Now
So
again, we want the positive of this arm, but the negative of this arm.
Okay.
So we've got negative 3x plus 5 equals x plus 1.
Yeah. And I'll rotate the 3 minus 3x over, and the plus 1 the other side. So 4x equals 4. X equals 1. We need to work out the y as well, the point of intersection.
Yep, we can do that one.
As each of them equal, that's y equals x plus 1.
Do 3 plus 1 for this one.
Yep.
Gives this to be 4. And then I would do 1 plus 1, which gives that one to be 2, like that.
Yeah.
And that's
Okay.
a mod with a mod.
Pretty simple as well. It's a little bit complicated with inequalities.
It does, unfortunately, it doesn't stop there. So now I have an inequalities example, if you want to rub it off again.
Alright, lots of rubbing off.
Again, if you're working from this book, it is example 5, the one right after it. It's a modulus with an inequality. Now inequalities here are a lot like they were in core 1, so try and refresh your memory there. Okay, you ready?
Yep.
We have mod of 3x minus 4, sorry, 3x minus 4 is greater than x plus 2.
Okay. So again, you should always draw it.
Always draw it. So it's going to go on positive 4 over 3, and it's going to have quite a steep little gradient.
Yep, and then it's going to reflect off that way.
Yeah, it would have gone down there.
And then you have an x plus 2.
Y equals x is just straight through the origin. X plus 2 lifts it up 2.
Yeah.
And it's not reflected or anything, it would keep going down.
And then it reflects
Not that it matters in this case.
way.
Except this one isn't a mod.
No, it isn't.
This
That
one
wouldn't be.
keeps going down.
Sorry. After the modern mods. I was
Bloody
ready.
mods. Mod mode. So it's got 2 points of intersection,
Yeah.
but it's an inequality, so it gets a little bit trickier.
Yeah. So, like the inequalities before, to start with you just ignore it.
You treat it as an equals at first. So first, do the positive of that.
Yeah, I would.
And it's this arm, we'll be looking at that.
Okay.
So 3x minus 4 equals, for the second, x plus 2. So probably take that x over that side and get
Yeah,
2x.
2x, and then that 4 over that side and get 6.
Yep, 2x equals 6.
So x equals.
X equals 3, except it doesn't equal 3.
It's actually
Greater
than 3.
And that would be there. So it's 3 onwards.
Yep.
Then we've got
Yeah.
the negative arm of this one with that. So you expand this out to negative.
Colour.
Lots of colour changes.
Lots of colour changes to be minus 3 x
Plus 4
equals.
just for the second, x plus 2.
Okay, this time do.
Probably take
Yeah,
that one
right.
over that side and that over that side,
Yeah.
yeah.
So it'll be 2 equals 4x.
So
X equals a half, except it doesn't. It's actually greater than still. Yeah?
Yes. Except not quite. Because you know.
Would it be less than?
Should be. I don't know why it's not.
It's because you times something by a minus, it flips the sign. You need to remember that it flips the sign.
He's got it. He's got
This is core 1 stuff.
It is core 1 stuff.
Well, it's quite rusty.
I'm a little rusty.
Yes. It's actually...
I'll practice an awful lot tonight.
Yep.
Because this is negative, when you times by or divide by a negative, the equality sign flips, which makes sense. It should be less than the half. That's what x should equal.
Yeah.
So it's this way. Which is good because that's what it is. If you remember from your quadratic inequalities, when it's greater than, it's either side. When it's less than, it's in between the 2 points.
Yes. So it's that and that. Not
that
as
would
a
be
super thing.
your final answers.
It would.
X is less, greater than 3 and less than a half.
Remember your rules and you'll be fine.
Don't forget,
Because that
be a
makes you
clever
better.
cracker.
Absolutely. School hasn't started yet. We're broken.
It's still the holidays. We haven't long been back from the Isle of Wight. It's dressed like a cowboy. I'm just not ready yet.
Not ready. But that's that. So the only thing that does extra from these is transformations.
Which you should be fairly familiar with.
Yep. We might have to look at the rules ourselves just in case something like that happens again.
But you can message us that. We're not going to run through it too much.
No, we're not going to do any working through. We might find an example if there is one with it in. If not, yeah.
So now on to a test yourself, which I think we need, if not you.
Okay.
In case you can't see it, 'cause it's quite small, you've got test yourself, question 5, page 37 from this book.
Absolutely. And I'll read the first one, you do it.
Okay, do you want to pass me a black pen though?
I
Mine's a
would
bit...
love to pass you that pen.
Cheers.
Merry Christmas. So, it says 5A is sketch on the same diagram the graphs of y equals modulus 2x plus 3 and y equals 2x squared plus 9. This is a thing that you should do in exams anyway.
You should be sketching it, even if it doesn't say sketch it, but if it does say sketch it, it's absolutely critical.
Yep. So, let's do that.
Let's.
I think we should do it in 2 different colours as well.
Okay, what colours do you suggest?
I think we should do it in red and blue.
Well, I think... No, I can't remember which of my red and blues work. You might have to chuck me everything.
Oh, I will.
I'll do this one first, just because I feel it's easier.
I think it's 2x squared minus 9.
Apologies, I didn't listen properly. And now what's the black pen? It's there.
Oh, there it is. Okay. There we are. I might have said plus, I didn't mean to if I did.
We'll see when it's on YouTube.
Yep.
Okay, so it's x squared, it's a nice quadratic, 2x
Yep.
squared, it's a steeper quadratic, and
Minus 9, all the way down there.
So it's fairly steep, and it's all the way down here.
Whoosh. Whoosh.
Like that. So it also says to put in all of the values, so I'll do this now before I draw the next graph.
So we know this one's minus 9 at the bottom.
Yep, so it's 0, minus 9 if you put it in coordinate form.
Yep. And to work out these 2 things, it's when y equals 0.
When y equals 0, what does x equal? Well, first you can take the 9 over that side.
Yep. Divide by 2, so 9 over 2.
9 over 2. And then you'd square, or you'd plus or minus, be careful of that.
Yeah,
The
square root of
these
it.
things equals x.
But remembering our third rules, you're doing something pretty jazzy at this point.
Root 9 over 2 is the same as root 9 over root 2. Root 9 is 3.
Yep.
So it's, this point here would be the positive, and it
It
would
would.
3 over,
Over the
root 2.
2, and the other side would be the minus of that.
Minus 3 over root 2.
Okay, so that's that graph. Swap pens.
Okay.
Now we have the next graph.
Now minus 3 over 2 is where it's going to touch the x-axis.
Yeah.
And is that smaller or bigger than minus 3 over root 2? You've got to think root 2 is smaller than 2, so if you divide by a smaller number, you get a bigger number, so it's a bigative negative number.
Yeah, so this one is less than.
And it's about the same steepness, but it's not a curve. So it's going to intercept there anyway. And this point here is going to be minus 3 over 2, as we just said.
Yeah.
And this point here
Should be
3. Yes.
Yeah.
When x equals 0.
0. So that's that bit sorted.
And I think that's all of part A. Is that all of us
I
have to
think
do?
that is part A, and I think part B is going to be something about finding the roots.
Well, let's
and how
see
often it is.
how wisdomist you are. 5B. First is deduce the number of roots. That's a nice easy thing.
So, 2.
2. One's here on the negative arm and one's here on the positive arm.
Sorted.
That's not all of B. It also says determine the value of each of these roots as expected.
Alright, so I think we should do the positive arm first.
Okay.
So we have 2x plus 3
All positive.
equals 2x squared minus 9.
Yes.
So, turn this into quadratic.
Always keep the squared, and whatever the coefficient of it is, positive.
Okay.
So you're taking all of this stuff over that side to keep the positive 2x squared. You get positive 2x squared minus 2x, and then minus 3 minus 9 is minus 12.
Okay, and we get half all of this, I'll do that.
It simplifies it. X squared minus x minus 6 equals 0.
And
This one you can put straight into brackets. You need two numbers that times together to equal that, and add together to equal that, or 2 and minus 3.
yeah.
So x plus 2, x minus 3, which means x equals the opposite to each of those things.
So it's either minus 2 or 3. Now we know it's this side.
So it has to be the positive version. You can just scrap the 2, because it's not that. That's what it would be if it kept going down.
But it doesn't.
So positive 3 is this
That's that point
intersection
there.
here.
So now we do the same thing, but
For the negative arm.
so I'll do that in green.
Okay.
So negative arm be
Negative 2x minus 3, and then equals the 2x squared minus 9 again.
then we just put these stuff over here again.
You do 2x squared plus 2x. You've got the minus 3 taken over and plussing it onto minus 9 is minus 6.
It is.
And
Again,
that
you can
equals 0.
steal half all this.
You can. It's x squared plus x minus 3 equals 0. This time I don't think you can
I
put
can't
it in
think
the
of one.
brackets.
So I have to do the quadratic formula, which is
X equals, this is core 1, but you should still remember, minus b plus or minus the square root of b squared minus 4ac all over 2a.
like that.
Just like that.
So, now remembering what our A and B and C are, B is 1, so it's minus 1,
Plus or
so
minus
minus
the square root.
of
1 squared is 1. Minus 4 times 1 times minus 3 gives you plus 12. All over 2a, and a is 1, so it's over 2.
So then we know we minus 1 plus or minus the root of the...
1 minus 12, oh, that's a plus.
Yes.
You've got to be careful of these things. So it's plus or minus root 13 over 2.
What am I doing?
Down here, mate. Over 2.
We know it's going to be, I imagine it'll be the negative one.
It would have to be, yeah. Because you think
If it's the closest one to that, below it is
root
9.
13 is going to be in between 3 and 4, the positive version. If you do minus 1 plus that, it would be way too positive to be this point.
Yeah,
So it has to be the negative.
minus 1 minus root 13 over 2. I don't think you can simplify that either, unless you could do half. Minus a half, minus half root 13, you could do that. But I think that looks even messier.
I think it does.
So I think we should leave it like that. Maybe write the points on.
Yep. Trying to think of the easiest way to do it. I
guess
just
you
write it exactly like that, I think.
Yeah.
There's other ways of expressing this exact thing.
Put half in front of it and put it in brackets. You could do a
could.
few things, but you probably don't want the plus or minus.
Oh, sorry, you just want the minus. That's right.
Over
13 over 2.
2.
You could write minus a half and then times it by minus 1 minus root 13.
Yeah.
And then when you expand that, it would give that. But I'm just going to write it in that form. Don't know what the answers do, but is that.
the same thing, and that's how you do that. It doesn't get much more complicated than that, really.
That was a pretty hard one, and it's from 2001. The syllabus has changed, but not very much.
No, it's still this sort of thing. And the only thing that gets worse is transforming, which is what we're on to next, but first...
Summary.
Summary time.
Yep, this is chapter 2 of core 3, and it's
The modulus function, which is a new thing, but just makes everything positive.
Yeah, pretty much. It's the absolute value it's referred to as, and it's really the distance from 0 on a number line.
Yeah, which is why it's always positive, because distances are...
Except you apply it to graphs, which means that where the graph would be negative, you flip it up.
Yeah.
And then there's transformations, which we didn't go through because you know you transform, or you should.
And that's what we're going on to next.
Yes. So you can sometimes get modulus that do the V shape, but then it's reflected in the x-axis, so it actually does that, and it is under. That's about as weird as it would get.
But you do the reflection first.
You do. So, I hope all the skills of this are transferable to further units. You'll probably use it again.
Yes, almost certainly. We didn't use the composite functions of this, but you can do.
Can do.
Because again, it's a function.
The transforming graphs that we didn't go over is the next chapter, so we'll see you there.
Yeah. And as usual, if there's any more questions, it was quite a short summary, but it's quite a short video, really.
Yeah, there isn't much to say. It's all about the absolute. It's just getting the graphs correct. That's quite difficult sometimes.
If you've got any more questions, you can send them to us, but it's pretty much what we did in the video lots of times.
Yep, but if you do come across a question, you can find us on Facebook at Clever Crackers Squared, which you can find the link on our YouTube channel. Or you can leave it in the comments below. We'll read it and we will try to get you with
we'll make a video.
Easier on Facebook, because then we can private message you back the video, so it's just for you, but whatever's good for you.
Yep. And that's it, really.
I've been Wayne Lack.
I've been James Rivera.
And this has been Clever Crackers Squared, Chapter 2, Core 3. See you at Chapter 3 of Core 3.
I think we should get a cup of tea.